Hello, Algebra 1. Let's look at the third part of the notes over the concept ratios, percents, and proportions. So in this concept, we're going to continue our look at ratios and rates, and we're going to expand it by talking about proportions. A proportion is a comparison of two ratios. And so remember, a ratio is a comparison by division. So when you have a proportion, you're going to set one of those ratios equal to the other. And then cross-multiplying is a method that we're going to use to solve a proportion. So the definition to get down is to cross-multiply. This is a method used to solve a proportion. Now let me show you an example of a proportion just using some general variables, A, B, C, and D. So we could set up one ratio and just say A over B equals, and then our second ratio, C over D. So when you have one ratio equal to another, that creates a proportion, and then if you have an unknown in that, you can solve for that unknown. And now let's look at this cross multiply. So I'm going to use this same example. So you can take the numerator of 1, you can cross the equal sign and multiply it by the denominator of the other, and then do that same thing on the other side of the equal sign with the other denominator and numerator to solve a proportion. So it would look like this: A times D equals B times C. And you can see my red lines indicate the variables that we're going to be, or those terms we're going to be multiplying together. So let's jump in and do this conversion that we are familiar with. So how many gallons are in 20 quarts? So now we're going to set up a proportion. Notice we're looking for gallons. So that's going to be our unknown. That will be our variable. And so we'll set up the ratio of gallons to 20 quarts. So we'll say X gallons over 20 quarts. And then we're going to set that equal to an equivalent ratio. And so if you look back, or you can just look right up in that conversion table, remember that for 1 gallon there are 4 quarts. So we will set that equal to the ratio of 1 gallon equaling 4 quarts. Now we have one unknown, which is our X number of gallons. So we'll solve for that unknown, and what we're going to do is cross multiply. So we will take the numerator on the left times the denominator on the right. So we'll have X times 4, which will give us 4X. And then the other part of our cross multiplying will take the denominator on the left times the numerator on the right. Now we are not focusing on our units as much as we were with that unit analysis method. So here what we're solving for is gallons. That's what X stands for. So we're going to go ahead and just divide out, follow the math, and we can divide each side by 4. So our answer will be that there are 5 gallons in 20 quarts. And that's how you can use a proportion. So let's try another one. So the property tax for a home is $1.45 per $100 value in the home. So for every $100 of value in your home, the homeowner will pay $1.45. If you live in a home valued at $210,000, how much will you pay in property taxes on the home? So first let's set up a ratio comparing the tax that we pay per the $100 value in the home. So we'll just say $1.45 in tax over or compared to the $100 in the value of the home. Now we'll set that equal to another ratio. So we are looking for how much we will pay in property taxes. So that will be our variable in our first numerator. And then our denominator will be the actual value of that home. So now we can cross multiply. So we'll take the numerator of 1 times the denominator of the other. So I like to start with the pair that has the variable. I'm going to drop my units now and just focus on my numbers and variables. So 100 times X is 100X, and that equals, and then I'm going to multiply my other pair. So my 145 times my 210,000, which gives me 304 1,500. Now let's just solve for x, so divide by 100. And remember that x equals, or what we're looking for, is the tax paid on the house worth $210,000, which will be $3,045. Proportions are good to use when you are scaling things. So maps use scales, and on this particular map, the scale is 1 centimeter equals or is equivalent to 80 kilometers. Notice that ratio is using the colon like we talked about in the earlier concept. What is the distance between towns that are 3 centimeters apart? So to set up this proportion, first we'll start by setting up our ratio of 1 centimeter to 80 kilometers. And then we'll set that equal to what we're looking for. So we're looking for the distance between towns that we know are 3 centimeters apart. Now, in a proportion, we want to have the same units across from each other. So that means in our numerator of our second proportion, we're going to have the 3 centimeters. And then what we're looking for is the distance, the x number of kilometers. So now let's multiply. Let's start with the pair that has the variable x. So we will take 1 times x, which equals x, and then on the other side of the equal sign is the other product, so 80 times 3. And that tells us that those towns would actually be 240 kilometers apart. Proportions are also useful with medicine. So a nurse gives medicine to a child based on the child's weight. The medicine is prescribed at a ratio of 40 milligrams for every 2.2 pounds in weight per day. If a child weighs 25 pounds, how many milligrams of medicine should be given to the child in each dose of the medicine, which will be given twice a day? So let's start with that ratio of medicine to weight. So for every 40 milligrams, for every 2.2 pounds, a child is given 40 milligrams. So now let's set that equal to what we're looking for. So we know the weight of the child, that will go in our denominator, and what we're looking for is how much medicine. So x number of milligrams compared to 25 pounds. So let's start multiplying with the pair that has the variable. So 2.2 times x equals 40 times 25, which is 1,000. So let's solve for x by dividing both sides by 2.2. So this is how much medicine should be given the child, 454.5 milligrams. But we need to give that in 2 doses. So let's divide that by 2. So each dose should contain 227.25 milligrams, so that the child is not given too much of that medicine. The examples that we just looked at were all real-life examples. You can also just have an algebraic equation that's set up as a proportion to solve. And you know it's a proportion because you have one ratio or fraction equaling to another. So in that case, you can always use the method of cross-multiplying. We have variables in both, so let's just take the numerator of one times the denominator of the other, and then set up our equation. So we'll have 9x equals, now notice we're going to have 2 times that expression, so make sure you put that expression in a parentheses. Now we'll just follow the math. So we need to distribute that 2, so I'll bring down my 9x and my equal sign, and then take 2 times 3x, which is 6x, and then 2 times 5, which is 10. Now I know that I need to get variables on one side of my equal sign and numbers on the other. So I can subtract my 6x from both sides. And then I need to isolate the x, and so it's being multiplied by 3, so I'm going to divide by 3. Now if you are not asked to round, we're going to leave our answer just as a fraction. We do not need to turn that into a mixed number. So 3 1/3. We can just leave it as 10/3. And we would want to simplify the fraction if we needed to, but in this case we don't. So that concludes the third part of our notes over ratios, percents, and proportions. And remember, in this section we were focusing on proportions, which is where you set up an equation with one ratio equaling another, and then solving for an unknown.